Alright, ladies and gentlemen, this is going to be our next unit on genetics, and specifically looking at understanding the difference between genes and alleles. So let's get started on this next video. So what is a gene? Let's go through and remember what a gene is based on what we've talked about. A gene is going to be a very specific segment of DNA, usually 10 to 50 kilobase pairs long, and it's going to code for a specific protein in your body. So if we look through our DNA, you're going to have this small section that is going to code for a specific protein. At the beginning, we have our promoters and everything that we've talked about with the central dogma. And what this is going to do is allow for this section to be converted into mRNA that is then going to meet with the tRNA and the ribosomes to make that protein in your body. A specific section could be for something like hair color, eye color, any of these different variations that you see in your body or in other organisms is encoded in these specific segments called genes. Now, in order to understand alleles, we have to understand sexual reproduction, and this is going to involve the fusion of two separate parent cells. So we're going to have a male and a female that are going to fuse their gametes together, and that's going to create an organism. And this organism is going to be genetically distinct. So the fertilized cells are composed of both gametes from both parents. So the offspring is going to be genetically different. It's genetically different from the male and the female because it's a combination of both. So let's try to better understand what this means. Well, when we go through meiosis, remember, we create cells that only have one set of these alleles here. We have haploid cells. And what we do when we create the zygote is we go from a haploid cell to a diploid cell. And this means that we are going through and putting allele from the egg and an allele from the sperm cell, or a chromosome, I should be saying, from the egg and a chromosome from the sperm cell. We're putting them together into the zygote for a diploid cell. So it's a combination of both the male and the female's genes and chromosomes. So then what is an allele? Well, if we're thinking about this, let's go through and look at our zygote. We have a chromosome from the male and a chromosome from the female. And if we went through that chromosome, there's going to be a very specific section, which is going to be a gene. And let's say this gene is going to code for eye color. Let's say on the male chromosome, this one codes for blue eye color. And then on the female chromosome, it's going to code for green eye color. Well, both of these are very specific genes from both the male and the female. Now, an allele is the different forms of that gene that ultimately influences what the offspring looks like. The allele is both of these genes here. You're getting two copies of a gene from mom and from dad because both of them are passing on genetic information in a diploid cell. When you were created via zygote, and we're getting genetic information from two organisms here. Same thing for any offspring that sexually reproduces. So if we're looking at this, the two genes are going to influence the phenotype, or what the organism looks like. We're going to go through and talk about dominant and recessive alleles, codominance, and all those things together. But an allele is simply the region of that DNA in which the two copies of those genes from mom and from dad are going to be. So if we're looking at this a little bit more, again, remember, a gene is a unit of heredity which transfers from parent to offspring the genetic information. And you are getting information from both mom and from dad. So if we're looking at this, we get two genes and two sets of information which ultimately influence what an organism looks like and then what you look like based on these alleles. So let's go through and look at an example of alleles. Well, let's say we are looking at the alleles that will determine sex of an organism. If you are a female, you have two X chromosomes, and this results in a female, whereas if you are a male, you're going to get an XY chromosome, which is going to result in a male organism. The difference between having XX or XY will influence the sex of that organism when we're talking about sexual reproduction in humans. So these chromosomes and the way that they're passed down and distributed and then form and come together in a zygote will ultimately determine the sex, eye color, hair color, all of these different phenotypes that we see in organisms. So alleles have a major impact. So if we think about this, well, we've been studying this for a while, and what we've been able to do is look at the human genome. And a genome is simply the entire set of genetic instructions in each organism. And the Human Genome Project mapped out the entire genome of one human, and this resulted in the discovery of over 21,000 genes. Now, what we can do with this, and what we've done based on this research and information and this project, is now we can go through and sequence all of the different genes in humans' bodies. And because of this, we can identify what genes might put you at a higher risk for cancer or diabetes or heart disease. And what we can do now is identify where those genes are, and then maybe go through and influence how we turn those genes on and off to make that human or make that other organism healthier. So this has been a really, really important project because it's allowed us to really grasp and understand how the genome works, and then how we can apply that to medicine to make humans healthier and live longer, and then bring down the expenses in the medical field. All right, so did you guys learn? Well, did you learn a couple of things? Did you review what a gene is? Did you guys go through and understand what an allele is? And then did you guys understand how alleles play a role in genetics? This is going to be the end of the video. I will see you all in class tomorrow.